All right, 3.1, two variable data set. So we're just going to fill in the blanks here. I'm going to talk about a couple definitions. Okay, so if you're asking what is a variable, so a variable, it's an unknown value or attribute that can be measured. Okay, anything that can be measured. Okay, and we're going to talk about one variable data. This gives the measures of one attribute. So one of those variables. Okay, one attribute. These are often displayed as, so maybe tally and frequency, okay, or bar graphs, pie graphs, pie in here, okay, or histograms. Okay, they're analyzed using mean, median, mode. They're just one set of data, okay, as well as range, variance, and standard deviation, if you recall that from grade 11. Okay, now two variable data. This gives a measure of two attributes. Okay, it compares the values of an independent and dependent variable. Okay, these are often displayed as ordered pairs, which is x, y. And these are also going to be scatter plots or two-column charts, usually x, y like that. Okay, and they're analyzed using correlations, linear regression, and nonlinear regression. Okay, correlation measures the strength of the relationship between two variables. Okay, and then we have scatter plot. Some people call this dot plot as well. This is a statistical graph. It's similar to a dot plot, and it's used to display the relationship between two variables. Okay, so when we're identifying situations, we have to ask ourselves these three questions. Okay, what is the information measuring? Okay, is it one or two things? Is it categorical? So is it like a word? Or are they both numbers? Okay, and how is it displayed, and how can the information be analyzed? So for example 1, what we're just going to do is we're going to state whether each involves a one variable or two variable data, and then we're just going to justify it. We're going to identify the data. Okay. NOAA researches annual hours of sunshine in Canadian cities. Well, this is the only thing that he is researching. Okay, it's grouped into cities, but it's just annual hours of sunshine. So I say one variable. Okay, a study compared. So as soon as we see comparison, we're thinking two things being compared to one another. The amount of time people spend watching TV and the amount of time reading. So this is one variable, this is two variables, this is a two variable data set. That's VAR. Okay, Franca researches students' hand span versus their height. Okay, again, two variables. Okay, let's talk about types of data. So categorical data is non-numerical data, so there's no numbers in it, and it just arranges into categories. So if you're talking about colors, you can talk about like who likes blue, red, pink, okay, green. Okay, so you can talk about like colors, farm animals, anything in kind of like a category. Okay, discrete data, this is numerical, and there are distinct numbers, so they can be counted. the numbers don't round forever. Examples of this is like number of goals scored. So in a basketball game or in a soccer game, you can't score 6.5 goals. That doesn't make sense. Okay, so goals scored in a game. Money, because always you can't go less than 2 decimals. You can't go more than 2 decimals, right? So it's 2 decimals no matter what. So those two we have to round no matter what, okay? But then we have continuous data, and this is data that can hold any value. So this is very difficult to visualize because these are things like height or any measurement or time. So when we actually time something and like say like you open your phone and it's like 000000, well, this is actually not exact because it rounds automatically at like this number here and it doesn't go past. But we're not glitchy. Like, we're not sitting in our bed 1 second, our feet hanging off the other second, standing up the next second. Like, we're not glitchy. We go smoothly. So time never ends and it never stops. We can't actually calculate time. You can probably better think of it as a measurement. So if you're this tall today, 6 feet, you're not going to wake up tomorrow and be 6'1", right? It's going to be gradual. You're going to hit every single number between 6 and 6'1" in that growth. Okay, so let's talk about displaying data. We can display it in a bar graph. So bar graphs are one variable. It shows the frequency of each data. Okay, obviously, like that's the number here, how many times it occurs. And this is used for discrete or categorical. Histogram we covered. Okay, this is a bar graph that touches each other. The difference between bar graph and histograph is that histogram is it shows a range. So if you remember, like here between 100 and 150, then 150 to 200. Okay, so it shows it over a range of data. So it can be continuous as well. Pie chart, this shows proportions. So it's like a percentage, and then you do a percentage of like 360 degrees of a circle. This is used for categorical. Okay, it's a really good visual of like the proportion. So this blue here is like the biggest proportion, and then the green one. So then you would like look at the legend. Okay, and then scatter plots are 2 variables. Okay, they have 1 variable at the bottom, 1 variable at the side. So there's 2 pieces of information, and it's used for discrete or continuous. Okay, example 2, part-time job study. So a survey of grade 12 students included a question asking whether they had part-time jobs. The table shows a tally of the results by a homeroom. So we're going to take a look down here. So let's talk about this. What is the independent variable versus the dependent variable? Well, the independent variable would be each homeroom, right? So homeroom. And this in here is categorical, okay? Because if we take a look here, it's numbers like 12A, 12B, 12C. It's just like a different letter for each homeroom. Okay, and then the dependent variable would be the number of students in that room with a job. Okay, let's calculate the frequency of each homeroom and let's fill in the chart. We don't need the information above anymore. So we're going to go for, these are grouped into 5, 6, 2, 5, 6, 7, 8, 5, 6, 7, 5, 6, 3, and then that's 5. Okay, and should the data be graphed using a pie chart, dot plot? So not dot plot like a scatter plot because that's 2 variable. We're only dealing with 1 variable. We can do a bar graph because a histogram is a range, but if you, like, there's no range on a one variable, so we can't do a histogram, not a scatter plot, which is the same as dot plot. I wouldn't do pie chart just for grade 12. Let's do the bar graph. Okay, so we're going to graph using a bar graph. So let's just call it part-time jobs. Okay, for the x-axis, we're going to call this homeroom. And I think this is as low as I can go. Okay, and then for the y-axis, we're going to call this number of students with part-time job, PT job. Okay, so we're going to call this 12A, B, C, D, E, F, G, H. Okay, and we're going to go 4, 6, 2, 8. So 4 is here, 6 is here, 2 is here. This is actually how I do it. And then I draw these lines in after. 7, 6, 3, 5. 7, or I'll go like that. 6, of course with the ruler. 3, and then 5. Okay, so what we're going to do is we're going to give 2 descriptive statements about the data. So I'll give a couple, okay? Most students with a full-time job or part-time job are in room 12D. Okay, so 12D, most students with part-time job. Okay, and you can do the least as well, which would be C, which is 2. 12C, least students with part-time job. Okay, if you want to calculate all of them, we can go we can just tell you it here. This is 10, 20, 36, 41. Let's go 41. Okay, 41 students in grade 12 have a part-time job. Okay, you can compare to, like, classroom D has 2 more students than classroom B, right? You can compare them as well, but those are just a couple of different descriptive statements that we can make. Okay, example 3. This table shows the results of a survey of 15 teenagers in which participants indicated their age, so 2 things, their age and the number of physical activities that they performed each week. Okay, so we have these, and if you think about these, they're ordered pairs. So this one would be 14, 3. Okay, this one would be 16, 0, and so on. So in general, what do you know about each person? Well, you know their age, you know 2 things. Okay, and number of hours of, I'm going to put PA, physical activity. Okay, so we know 2 things. So this is going to be obviously a 2 variable. Okay, and our independent variable is going to be the age. Independent usually has to do with time, if you have time in your question. And then the dependent variable is the number of hours of physical activity. Okay, so what type of graph would be appropriate? Well, since it's 2 variable, we're going to do scatter plot. Okay, and we're going to go ahead and graph this. I'm going to read these off my paper. So let's call this physical activity. And SY, so I put 2 variable. Okay, so we're going to graph age versus number of hours. Okay, so the first person is 14, 3. The second person is 16, 0. Third person 17, 4. 1, 2, 3, 4. 15, 10. 18, 1. And then 19, 6. 1, 2, 3, 4, 5, 6. And then 19, 5. 18, 9, 6, 7, 8, 9, 13, 10, 15, 0, 13, 10, 15, 0, 16, I want to say I put 1 down for this, 16, 0, 16, 14, 16, 0 again, which is fine, we already plotted that, 16, 14, 16, 10, 14, 7, 16, 10, 14, 7, and then 17, 0. Okay, so we have all these, with the scatter plot, we have all these dots plotted all over the place. So that's good. So is there a relationship here? I'm going to say no. If there was a relationship, it would be maybe like closer together and then we could put a line through it. But I'm going to say no. It's very scattered. Okay, and then we can pose a question that would require one variable data analysis. So a question that we can ask is, what's the total amount? Or we can say, what is the average? Average, remember mean, median, mode are all one variable. Number of hours of physical activity. And then we can also ask two variable data analysis, right? E is kind of one of those questions. So is there a correlation between age and PA? So those are just some things to think about, and if you think about it, this is how we would actually analyze this data.